The X1, the GNSS IN's high-precision combined navigation system, is based on the self-developed chips by Bynav technology. It contains a high-precision IMU and has the deeply coupled combined navigation algorithm built inside. It supports full constellations, multiple frequencies and dual antenna orientation, which can effectively deal with complex applications and scenarios. There is a power supply interface, 2 communication interfaces, an industrial Ethernet port and 2 RF ports. The DC power supply voltage should be between 9 to 32 volts, with a minimum power of 10 watts. A stable 12-volt DC power supply is recommended. COM1 includes the RS232 serial port COM1, PPS and event. The PPS output is 3.3 volt LVTTL with max 12 mA output. For time synchronization, COM2 includes the RS232 serial port, COM2 and CAN. You can feed the wheel speed data through the CAN interface. There is no functional difference between COM1 and COM2. If you need higher data transmission speed, please use Ethernet connection, which provides 4 ports. There is no functional difference between them. All support data transmission via TCP or UDP protocols simultaneously or separately. Besides X1 main cable and RF cables, you may also need to prepare a 12-volt/5 ampere power supply, as well as a laptop with a Windows operating system, to facilitate connection with the computer via the serial port. An RS232 to USB converter is also needed. When using high baud rates such as 921600, please ensure the cable also supports it. If you choose to connect with the computer via the Ethernet port, you need to prepare an Ethernet cable. Also, ensure you have RTK correction service, such as a valid trip account. The devices that need to be installed include the X1 and a high-precision GNSS antenna. Taking the installation on a sedan as an example, the box should be rigidly connected to the vehicle. It is recommended to fix the box with screws. If on-site conditions are limited, it can also be fixed with 3M tape. It is recommended to install the X1 with its Y-axis pointing in the vehicle traveling direction, the X-axis pointing to the right side of the vehicle, the Z-axis pointing upwards. The high-precision GNSS antenna, commonly known as the mushroom antenna, can be fixed on the roof of the car with a magnetic base. Here, we choose to install them along the vehicle traveling direction. The distance between the antennas is recommended to be greater than 1 meter. After the installation is finished, connect the antenna to the X1 with an RF cable. The ANT1 interface of the X1 is connected to the antenna at the rear of the car. ANT2 interface is connected to the antenna at the front of the car. Then connect the power supply cable to X1. Use an RS232 to USB converter to connect the laptop and X1, or an industrial Ethernet cable to do so. Then feed the power to X1 with a power adapter. Download ByConnect, the upper computer software, from Bynav official website. No installation is required after downloading and extraction. You can directly double-click to open it. Click the connection button to open the connecting setting module. The default serial port baud rate is 115200. After opening the serial port, you can try sending commands. If the box does not respond, you can change the serial port and retry. If Ethernet communication is used, please note the X1 default Ethernet configuration is as above. Then choose a port, such as 2222, enter the command and click the Send button. When the correct serial port is in use, please enter and send another 6 commands. In the RTCM config module of the upper computer software, enter the relevant information of the trip service. If the antenna on the roof of the car is in an open environment at this time, a fixed solution can be obtained quickly. Next is the measuring and setting of RBV and the antenna lever arms. RBV is used to describe the relationship between the IMU body frame and the vehicle frame. If the X1 is installed as recommended earlier, that is, with the Y-axis pointing in the vehicle traveling direction, the X-axis pointing to the right side of the vehicle, the Z-axis pointing upwards, you can directly send the command in the video to configure RBV. If it is not installed as recommended, then the 3 values of RBV may not be zeros. You can get the correct RBV values in by offset by choosing how you actually installed X1. Antenna lever arm is the three-dimensional distance from the IMU center to the antenna phase center. Measure using tools such as a tape measure as shown in the diagram, and obtain the three measured values of X, Y, and Z. Then return to the main interface of the upper computer software. Enter the command in the input box and send it. The marked contents are the ANT1 lever arm. The above operation can also be finished in the inertial navigation module of the upper computer software. Using the same method, measure and configure the values of ANT2 lever arm. Finally, send the commands saveconfig and reboot. After the X1 restarts, if correction data input is still maintained and the antenna are in an open space, in the lower right corner of the upper computer software, the first two indicator lights will turn green. The third indicator light will turn yellow. That is, the combined navigation has entered the mode of course alignment. If you plan to feed wheel speed into X1 later, you also need to complete the measurement and configuration of the NHC and DMI lever arms. The NHC lever arm is characterized by the three-dimensional distance from the center of the rear wheel axle to the IMU center. Insert the measured NHC lever arm values to the command and send it. To complete the configuration, the DMI lever arm is characterized by the three-dimensional distance from the geometric center of the wheel to the IMU center of navigation. In the inertial navigation module, we can enter the NHC lever arm measured in the previous step, the wheelbase and axle track to calculate and set up the DMI lever arms. Calibration is also recommended to minimize the IMU installation error and improve the positioning accuracy. Choose an open straight road where you can turn around the car. It is recommended that the length is not less than 1 kilometer. Drive back and forth on the road at a speed of not less than 18 kilometers per hour. Keep driving until the third indicator light in the bottom bar of the upper computer software turns green. In the command input box of the upper computer software, enter and send the command in Scalibrate RBV new. Keep driving the vehicle in the same way, paying attention to the source status field in the install status message. When it changes to calibrated, it means that the calibration is complete. Record the offset values of the X, Y, and Z axes at this time. Then send the commands saveconfig and reboot to save the calibration results and put it into effect. After the restart is completed, send the command log installconfig once. Compare the RBV offset values in the feedback with those recorded in the previous step. It works if both of them are inconsistent. Otherwise, you have to manually set up the RBV with the commands in the previous steps. Now, the X1 test platform is established.